being specific about randomization. Example 3, blocking by gender and LDL. So instead of looking at gender and family history, let's say that we believe that gender may affect the response to the statin, and let's also say that your starting level of LDL, for one reason or another, we believe that that level that you start with may also affect the effectiveness of the statin treatment. So let's focus on the female block here. I don't care anymore about family history. I care about the 10 subjects. They're all female. They're all similar in that respect. But I'm interested in making them similar in terms of LDL. So the first thing that's convenient to do, why don't we look at their LDL levels and list them highest to lowest in terms of their LDL level. So the highest LDL level is 201. I'll put that at the top. I think the next highest is 192. Then this 175 would be next. Here is a 168. Then we have a few more that are in the 100s. Here's a 137 and here's a 128. So we'll bring them up, putting them in order. I'm looking only at the LDL. I don't care about HDL or family history. So here are two that are in the 90s, 96 and 92. And here are the last two, 72 and 65. So this time, I'm looking at just the females. But there are two treatments. So the other strategy that I could do here is to make blocks of size 2. So notice these first two individuals are both female and they both have LDLs that are close to one another, 201 and 192. So maybe I make them a block of size 2. These individuals have LDLs of 175 and 168. They're pretty close, block of size 2. Here's a 137 and a 128. They're close. A 96 and a 92. They're close. And these are also close, a 72 and a 65. So these are blocks of size 2. And these blocks are similar in two ways. So this pair of subjects are similar in gender and also in that they have a similar level of LDL. So these blocks are of size 2 because now what I can do is randomly assign one of the individuals in this block to the statin treatment and the other to the placebo treatment, and then I can compare the differences in all of these blocks where within these blocks now I'm controlling for two factors. I'm controlling both for gender and for their level, their starting level of LDL. So let's explain what the randomization would look like in this case. So for each pair now in the female block, let's choose the subject with the higher LDL. So for instance, for this pair of subjects here, we would be looking at the subject with the 96 LDL versus the 92. It doesn't matter whether you start with higher or lower, you just want to be specific. So let's choose the subject with higher LDL, and we'll flip a coin. So if the LDLs are the same, I suppose we could choose the higher HDL. So if the coin lands with heads up, this subject receives the statin treatment. Then the subject with the, not the higher now, but the lower LDL in the pair receives the placebo treatment. Now you want to be very specific here. So instead of landing with heads up, let's say the coin lands with tails up. So in this case now, this subject, again, we're talking about the subject with the higher LDL. With tails up, this subject is now going to receive the placebo treatment. And the subject now with the lower LDL receives the statin treatment. So notice I'm being very specific about what happens if the coin lands heads up. I'm being very specific about which subject receives statin and which subject receives placebo. And likewise, tails up, I'm being very specific about which subject receives the statin treatment and which subject receives the placebo treatment. Then we would follow this procedure to complete the random assignment for every pair in the male block. we would pair up males by similar levels of LDL, and we could do a similar random assignment. So these are blocks of size 2. When your block is of size 2, shockingly, it's a pair, so we call these matched pairs. So they are matched in terms of similar characteristics. In this example, similar in terms of both gender and their starting level of LDL.